record, and let's get started. So let us continue with functions, as well as finally I'm going to show you how to animate things in Python. I mean, technically you've been making animations as the turtle moved around to draw your pretty pictures, but I'll show you like real animations, the kinds that you were doing in Scratch today. So that'll be fun. All right, the first thing that I want to talk about is let's just go back over functions again, because it's a big topic. It's a very important thing for the rest of your computer science career. You're always going to want to make your own functions, so I want to make sure that that's very concrete in your mind. So yeah, a function is just a piece of code that you can keep on running as many times as you want. You can say turtle.forward as many times as you want. That's a function, right? You can say math.square root as many times as you want, and it will calculate a new square root for you each time. That's a function. Okay. And to define a function, you say def, then you give the name, func name, whatever you want it to be called, and then you put some parentheses, and you give all the things that that function takes when it gets called. Maybe it takes two things. Stands for parameter. So a function takes parameters and it gets called with arguments that fill in for those parameters. Okay? So you tab over, you give the body of your function, do all your fancy stuff, and that's essentially how it works, right? Some functions don't just do something, they actually give a value back. They compute a value and they give it back. That's called returning. So if you say return inside of your function, that stops the function, that ends it, and goes back to whoever was calling you and gives back the value that you put right here after the return. Okay, so this gives back something to the user. And yeah, the way that this function could get called would be something like this, func name 42, 43. So the 42 is going to fill in for the P1, the 43 is going to fill in for the P2, and then it jumps up here and runs the code, and eventually it's going to give something back, right? So you'd want to use this function call, assuming that it returns something, you'd want to use it in a larger expression. You'd want to be like func name 42, 43 plus 1 if it gives back a number, for example. So some functions are meant to just be called on their own, just like func name, and they don't actually return anything. So that would be valid if it didn't return anything. But other functions do return stuff. You better save that value. Use it. Call your func name function on 42 and 43. Add 1 to the result. And use that value. Okay? So some functions, they're meant to be called like this. Turtle.forward, for example. Print. They're just called on a line by themselves. They don't need to return anything. They just do something for you. Other functions need to give something back, and you better either like take their value and build up a bigger value based on it, or like immediately print it out. You got to use that value that you get back. So that's the age-old question of like print versus, I don't know, math.square root. Call print on a line by itself, but it makes no sense to call square root on a line by itself because you're just throwing away the answer. You got to use the answer. Okay, some functions give back an answer. Any questions about that? Does that make enough sense? Is it coming back to us? All right. So for my example, let's make a function that draws stuff for a turtle. So let's make a draw rectangle function. And so the question is, well, okay, what in the world are we going to use to represent a rectangle? Because we're going to have to say, like, draw a rectangle. How do we say, hey, I want a rectangle, like, exactly right here? How do we say that? How do we tell Python? How do we represent that's exactly where I want that rectangle? What do we give it? Do we give it multiple parameters? What's that? Yeah, a coordinate could work. So a rectangle could be represented by like all 4 coordinates. You could pass along 4 coordinates. That would work. That's one way to do it. A slightly easier way with less information would be to maybe pass along just 1 coordinate, maybe pass along the upper left coordinate, say that this is like, I don't know, 1, 5, that looks about right. You can pass along 1 coordinate, and then you could also pass along like the width and the height. So there's the height, there's the width, 3 and 4. That also represents exactly this rectangle. Does that make sense to us? That's a little bit less information than having to pass a bunch of pairs of numbers. So just one pair, which is the coordinate of the upper left corner, let's say, and then the width and the height. Those are the 3 magical things that will represent a rectangle inside the computer. There's only one rectangle that has its upper left corner at 1, 5 and has a height of 3 and a width of 4, right? That's the idea. So that's how you can represent a rectangle. With that, we can make a draw rectangle function. So we need to give it parameters. So I guess we're going to have to give it, well, we need to give it the upper left coordinate of the triangle, or not the triangle, sorry, of the rectangle, and then the width and the height. So it's going to take 3 parameters. Does that make sense? So def draw rectangle, that's a weird looking W, draw rectangle. So to draw a rectangle, we need to pass along the upper left coordinate of the rectangle, the width of the rectangle, and the height of the rectangle. Okay? And so I think you can imagine how you're going to have to implement this. You're going to have to tell the turtle to be like, I don't know, this is the exact rectangle we want to draw. It starts at this coordinate, UL. Maybe we want to like start facing right. Draw width, draw height, turn around. It's like a concept of go to UL, ... Okay, that's going to be what we do. That's going to be how it works. We're going to make our rectangle, this particular rectangle, we can call draw rectangle like this. We can say draw rectangle with the coordinates, the 1, 5, right? And then the width and the height, which was 3. Okay. That's how we're going to call this function. And we have some little parentheses inside. So let me teach you what that is all about. Okay? That's called a tuple. Maybe I should put this picture on the other side, but let me go into idle. Some people pronounce it tuple, but I learned it tuple, so that's how I'll say it. So you know how you can have lists with angle brackets, square brackets, 1, 2, 1, 5? That could represent a coordinate technically, but if you replace those, and the type of that, right, was a list, you could replace that with parentheses, 1, 5. You can make it as long as you want, 1, 2, 3, 4, 5, doesn't matter. It works almost like a list, but it's called a tuple. What's the type of, in parentheses, 1, 5? It's a tuple. It's slightly different, right? A tuple works almost exactly the same as a Python list. So I can set a variable equal to a tuple, like UL equals 1, 5. UL, it's 1, 5. It's saved there. I can go into it and get those coordinates, like the x coordinate, UL is UL of 0. That gives me the 1. UL of 1 gives me the 5. So I still use those angle brackets to get out those pieces of it. But you can write it like that with parentheses. The one thing it can't do, the one thing a tuple can't do that a list can do is set elements. Like I can't set the 1 to be a 42. Tuples cannot be set anymore. They're like read-only. Once you make them, it's set to be 1, 5 forever. Lists can be changed. So, yeah, that's what a tuple is, and we'll use those to represent our coordinates. Why not? It looks like a coordinate. So, yeah, so we discovered that to represent a triangle, we have to have a way to exactly say which triangle, oh gosh, I keep saying triangle, sorry, rectangle we want to draw. And so we have to save maybe its upper left corner, and then we'll save the width and height. Okay, you could do it for any other corner too, depending on how you want to think about it, but this will pin down a rectangle in space, exactly this one, and we'll use tuples to represent the coordinates. So we'll pass along, as one big thing called UL, a tuple of an x and y coordinate, right? So 1, 2 is a tuple, 1, 2, 3 surrounded by parentheses is a tuple. It's essentially just a bunch, it's just a list with the square brackets replaced by parentheses, okay? Maybe we want to draw a colored in rectangle. We can also add a new parameter for the color, maybe. That would work too. But let's just do it this way for now, okay? That is our goal, to make this draw rectangle function. All right, so let's figure out what lecture we're in. I'll make a new file. And I'm going to save this in a folder for today, but I have to figure out what folder should be today. Oops, we're not spring. Something bigger than 22. So we're lecture 24 today. Let's see if I can remember to save it inside the folder for once. There we go. So I'll call this draw-rectangle.py. All right, so yeah, let's make this function. Let's make it happen. I'm going to import turtle, of course. I have to use the turtle library. And then turtle.shape, turtle, as always. But I would like to make a function called drawRectangle so that I can do stuff like this. Draw rectangle, I don't know, 50, 100. That could be the upper left corner, and then it could be, I don't know, 200 wide by 300 tall. Something like that. Okay? Let's try that. So I would like to make a function so that I can call it like this. Def draw rectangle. We had it over here. There it is. So it takes an upper left corner coordinate, a width, and a height for my rectangle that I'd like to draw. Alright, so I guess the first step is move to the upper left, face right, and then draw the rest of the rectangle. Draw the width, turn right, because I'm going to be facing right, draw width amount, go forward by width, turn right by 90, go forward by height, just standard rectangle drawing at that point, just with variables involved. Turn right 90, go forward by height, and then the rest as you would normally do. Alright, so let's move to UL. So turtle, we don't want to make any points while we don't want to draw any marks while we move to that place. So turtle.up, and then you can totally say, technically turtle.goToUL should work, but let's pick out the x and y coordinate, because usually we call goTo like this, like 42, 57, right? So I need an x coordinate and a y coordinate, and it's buried inside of UL. UL is one big tuple of two things. But I can extract the x-coordinate and the y-coordinate by using those indices. So it's UL of 0, that's the x-coordinate, and UL of 1 is the y-coordinate. Does that make sense to us? Any questions about that? And now we're ready to draw. Turtle.down. Okay. Face right, turtle.set heading 0 is east for some reason. And then we'll draw a rectangle. So we've moved the turtle to the upper left coordinate, whatever the user asked for. Now we're facing right. Now we're going to go forward by width, turn right, go forward by height, turn right, go forward by width, turn right, go forward by height. That draws the rectangle. Turtle.forward by not like 100 or something, but the width, which is W. Then turtle.right 90, turtle.forward by the height, and then the rest. Turn right again, now it's width again, and then another 90 and height one last time. Okay, so that'll draw a rectangle. All this code will draw a single rectangle at that particular spot that the user asked for. Here is where I'm asking for it to be drawn. Let's try it. Hey, so there's my rectangle. Yay. And the beauty of making functions, though, right, is so that I can call it many times. I have abstracted what it means to draw a rectangle, so it's really easy for me to draw a bunch of rectangles now. I just call draw rectangle with different arguments. So maybe I'll draw a rectangle at -50, -100. That could be the upper left. And then it could be tiny. It could be 50 by 30. And now I'll have two rectangles. Well, it'd be nice to be able to see it. Try again. There it is. Two rectangles. Just as we intended. Are there any questions about why this is working? So I can call draw rectangle as many times as I want. Let's make one last one. A rectangle with the upper left coordinate at 0, 0. And it can be, I don't know, it can be a square, so like 75 by 75. That'll do it. And then we got some overlap. Why not? Any questions about how that's working? Why it's drawing a rectangle? So the second I call draw rectangle, no matter which call, it's jumping up to this code, but it's setting the names of the parameters to whatever we supplied in the argument. So for this particular call down here, the second call to draw rectangle, UL is going to be set to -50, -100. The width is going to be set to 50. The height is going to be set to 30. Yeah? That's pretty nice. We could go further, though. Let us add an extra final parameter for the color that we would like the rectangle to be drawn with. We'll use like begin fill, end fill. Won't that be fun? Let's add a color parameter so we can draw different colored rectangles like this. We could do, I don't know, can do an all black rectangle, why not? We could do a red rectangle. We could do a blue rectangle for this one. There'd be some overlap too, which might look cool. So these are the kinds of things that we'd like to do. So we'll just add one more parameter. We call it color. And gosh, I guess let's not fill it in. Let's have this be the outside color. That's easier to do for now. But I encourage you to try to do it for the fill color. This would just be a turtle.pen color. Set it to whatever the color is. That's the outline color. It's still not filled in. But just that one line, if I can find the window, gosh. The screen is a little too small. Come on, turtle. Where are you? There you are. So draw in black, draw in red, draw in blue with the pen color, not the fill color. So that looks cool. Any questions about that? You can add another one for the fill color if you'd like. You have to like set the fill color, say begin fill, say end fill. I'll leave that as an exercise for you. But are there any questions about what we've done here? We made a function so that we can use it very easily, very quickly, a bunch of times. All right, for my next trick, let's make a function that draws not rectangles, those are easy now. Let's have them draw letters. Let's make a function that draws letters. So remember your assignment where I had you draw your initials and then like your graduation year. Mine was 2020. So that for me. But what if we made a function that didn't draw a rectangle but drew a letter that's resizable? Like you could provide, just like a rectangle, you could provide a width and a height and an upper left coordinate for a letter. Like this could be a draw L function with a certain starting upper left and a width and a height. And we could make a function that drew an L, just like that. Do you see how a rectangle is secretly involved in drawing a letter? There's like the bounds of it. That's how you would draw that L. Or maybe you could call the function again, make a draw L function, and have it draw a skinny and tall L. Upper left, width and height. So you can make a function that just knew how to draw L's given a starting coordinate for its upper left and then a width and a height. And it could just as easily draw this one as it drew this one. That's pretty cool. Let's do that. Let's make a resizable N character for my, that's a little bit more interesting. That could be my last initial, okay? I encourage you to try it for yours as well. So we just noticed, right, that you can bound any letter inside of a rectangle, which we now know how to draw. With that in mind, if the user passes us a rectangle or gives us a way to represent a rectangle, like upper left, width, and height, we can draw a character in that rectangle space. That could be like a bounding box for it, okay? So I'd like to make a draw N function, def draw N, that takes an upper left corner for the N, a width of the N, and a height of the N, and it goes off and it draws an N depending on how the user asks for it to be drawn. Maybe this is the upper left, the width is like this, it's bigger than the height. It would go off and draw an N like this, right here, right? And or if the user asked for this width, this height, and this coordinate up here, that could be its other upper left, it could go and draw an N like this. That'll be fun. So let's do it that way. So the idea is we need to figure out, we know how to draw a rectangle given an upper left, a width, and height. We have to figure out how to draw an N or any arbitrary character given an upper left, a width, and height. All right? So let's break this idea down. How are we going to implement this? Here is the idea. So regardless of what the user gives us, right, we're going to have to, the easiest way to draw the N, as we have discovered, is to use go-to, right? A bunch of go-tos. So like start down here, go up here, go-to over here, go-to over here, that draws the N. So we need to figure out the corners of all these, of this rectangle, right? Here's the upper left. We're given the upper left, right, as an X and a Y coordinate, right? It's a tuple of things. We're also given a width and a height, and we need to draw the N like this, right, which involves some go-tos. We need to figure out the coordinates of all the corners. Like we start down here, go to the top, go to XY, go to the other corner, then go to up, right? Something like that. Let me make that slightly more clear. So, boop, boop, go to here, and then finally go to up here, right? And in order to do that, we need all those coordinates. We need to know what's this coordinate, what's this coordinate, what's this coordinate. Because if we knew all four, right, we could start at the bottom one, go to this top one, then go to this one, then go to this one, and that would draw the N, right? So what is this coordinate given that we know that the upper left coordinate is that X and that Y, okay? So this is going to be some math involved. So this coordinate, whatever it is, it's got the same X, right? It's got the same X, but the Y has changed, right? The Y is a little bit lower than this upper left's Y coordinate. How much lower? Y minus, well, it's minus the height of this rectangle. Do you see that? So this coordinate must be X, comma, Y minus H. Does that make sense to us? Because once we know that, we can figure out any coordinate inside of this rectangle, and then we can use our go-tos to move around it, okay? And, all right, what is this coordinate over here? It's not the same X, but it is the same Y. It's X plus W. It's moved over to the right more in the positive X direction by the width of the rectangle. X plus W. The Y is the same. It's the same line on top there. Same height. And finally, that makes this one, it's X plus W. It's this coordinate moved over, right, on the X. And it's also down on the Y. This is the Y up here. We need to go down by H to get the new Y coordinate. y minus h. Does that make sense how I just figured out the four corners of this arbitrary rectangle, given its upper left coordinate and a w and an h value? So no matter what the user gave us, call that coordinate xy, call the width w, call the height h, I can figure out all four corners of that rectangle that's supposed to bound this letter. And that will let us make a function. It'll look almost exactly the same. And instead of drawing rectangles, we can draw ends. So I'm going to get rid of the color parameter. That overly complicates it. We're going to make this function called drawN. It's going to be very similar, right? It's going to involve essentially reading off the code from this diagram that I drew right here. Let's see if I can move it over a little bit. Shrink it a little bit too. I think that should work. I got more room here. All right, so what does it mean to draw an N? Well, I know what x and y are. That's inside of UL, right? The x is, so we passed it along like this. UL is going to be set to a tuple that looks like this. The x coordinate is the first thing of UL 0. The y coordinate is the second thing of UL 1. All right, now I need to draw a width by height N character. So we need to start, right? Where do we start? Because we're going to use goto. We don't start up here at the UL anymore. We start at... Come on, PowerPoint, did I just freeze you? My computer's not happy about running Zoom and the recording and everything all at once. Oh, okay, I think it's better. No? I can do this, but I cannot do anything else. Interesting. What if I minimize you? Ooh, okay, that's a bit of a problem. Sorry, technical difficulties. Ooh, it doesn't look like PowerPoint's trying to do anything. Did it complete its problem? Okay, cool. Back to normal. So I was trying to draw. Where do we start when we go to? We start down here at this coordinate. So start at x, comma y minus h. Which just means go there. Tell the turtle to go there. Turtle.up, then turtle.go to x, comma y minus h. Exactly that. Turtle.down. So now we're ready to start drawing the end. Right? Now I go to every other coordinate. So we start down here. Now we need to go to here, go to here, go to here. If we do it in that order, it will draw the end. So turtle.go to xy, turtle.go to x plus w, y minus h, and then finally turtle.go to x plus w, comma, y. Took a little bit of math, but once we did that, this is going to be called draw-n.py. Once we did it, we were home free. There's one n, there's another n, there's a third n. Cool. Are there any questions about how this function and these calls drew what was on the screen? You can do that with any letter. Make it as wide, as tall as you'd like. can change the color. You can add another parameter for the color if you'd like. You can make a much fancier version of maybe the program that you turned in for your programming assignment. You can duplicate your letter as much as you want now that you've made a single function for it. Are there any questions about that? All right. If we are happy, I have a challenge for you. Here's my question for you. I'll give you like 5 minutes to try it. Please take my code, change it to draw a resizable L or any character that you want. Maybe your first initial, maybe your last initial. It's going to be the same idea. You're going to be passed along a bounding rectangle for the letter, right? UL, a width and a height. And it's your job to draw a letter inside of that box, right? Maybe if the user passes along this particular bounding box, bounding rectangle, you'll have to draw an L that looks like this. So take some time to look at my code. I'll give it to you on Discord if you want to copy and paste it even. Let's see if my computer can handle opening Discord though. But I'll also leave it up. So take this, make a draw something function. Draw L, draw your, a letter that's important to you function. So give that a try. And draw a bunch of different versions of that particular letter. Come on, Discord, you can do it. Put it in our CSCI 1 channel. Yay, it's there. Now I will close Discord before my computer blows up. Yeah, so take a few minutes to try that, and I'll be here to help you. few more seconds. Move on. All right, were there any questions that came up while you were trying that? Any errors that we didn't fully understand? All right, yeah, that's a good way to practice with a letter that is important to you. All right, for the last piece of today, which is going to take a while, I'd like to teach you animation. And the first animated program that we will write together will be just a program of a ball dropping. So it's just we're going to make a screen, we're going to make a little circle, and then we're going to have the circle, like, I don't know, here, let's do it this way. We're going to make the circle go like this. It'll start up here, it'll move down, it'll glide down, bounce off the bottom, go up here, bounce off the top. So it'll just go up and down in one axis only, just the y-axis. So it's just a ball that's going to move up and down, just like that. That is going to be our program. So it'll go down, and then it'll come back up, and just forever, until the end of time, bounce up and down. So that will be our first animated program. Yay! All right. So things get a little bit more complicated when we use Python. We have to program animation. So let me kind of teach you what animation is all about, because this was all taken care for us in Scratch. So what is animation? But it's kind of like this picture, right? Animation is just a bunch of pictures being thrown at you very quickly, right? It looks like a video. That is, like, you have a little old film, right? A little film projector. It's got a bunch of little frames that it's throwing at you. These are called frames. And like something changes a little bit, and that makes it animation. Animation is just moving pictures, a bunch of images shown very quickly to your eye. It looks fine, all right? And every individual image is called a frame. Maybe you've made like a flip book before. That was popular when I was in elementary school. But if you want to make a ball dropping, right, you have to make a frame where the ball's at the top. The next frame is going to be the ball has moved a little bit, so maybe the ball's down here. The next frame is going to be the ball's moved a little bit more. Maybe the ball's right here. And if you show this quickly enough to a human, it looks like a video, right? That's all that video is. It's just a bunch of still images being shown to you very quickly. Those are frames. Does that make enough sense? Have we all heard of that before, maybe? And you have to make a decision how fast you would like to show these pictures to the user, right? When the images change faster, you have what's called a faster frame rate. And so a very common frame rate in movies, for example, is 24 frames per second, or something very close to that. Frames per second, or I should just say FPS. 24 frames per second. So that means every 1/24th of a second, it shows you a new frame. Do that quickly enough, it looks like a video. Or it looks like it's real life. That is what it means to be a video, okay? So luckily with Scratch, we don't have to really worry about this too much. We can just try and do things as fast as possible, and the turtle will either catch up or it'll go slow. But you have to think about this when you're making a video game or you're making some kind of digital animation, all right? Scratch was very nice to us, wasn't it? So here's our program. Let's make a ball. It's going to get dropped, and it's going to keep on bouncing forever until the end of time. Okay? So first of all, what I'd like to do is draw a little stage for the ball to be dropping on. So the very first thing I'm going to do in the turtle is I will draw a giant rectangle, or maybe a square. I'll draw a giant square that is the stage where the ball will be dropping. Right? I've defined the end points of it. All right? So this will be I've discovered that 400 by 400 is a good spot, and let's have this centered on the screen, so we'll make this negative 200, positive 200. This will be the upper left of that bounding box, bounding square, and then we'll set the ball on the very tippy top of that, and that's where it will start dropping, all right? So that's going to be the idea. So I will eventually make a draw frame function in a second. We're going to draw a bounding square first, have a ball bounce off the top and bottom walls. Okay? It's just going to move at a constant speed right now. In a future lecture, I'm going to add physics. I'm going to give you a very rudimentary physics engine, and I'm going to make the bouncing look real. So like it'll speed up as it gets closer to the ground, and it'll bounce off in a nice looking way. But right now, it's just going to be a constant speed, move up, move down. All right. So let's get that bit first. Let's get the rectangle being drawn, this bounding rectangle. Let's get a circle being drawn up here. Okay, the filled-in circle. So let's start with that. So let's steal the draw rectangle function. I'll steal this. File new. So there's draw rectangle. I'm going to get rid of the color. No more pen color. Thank you very much. And the very first and only rectangle that I'll be drawing is that bounding rectangle, which was 400 by 400, starting at -200, +200. All right, so that will be the start of it. This will be called, I'll call this bounce.py. And if I run this, it'll just draw this bounding rectangle. That's just fine. Okay, so that's going to be the stage. This is going to be the screen that we're looking in on where the ball is going to drop. And so I'd like to start the ball just so it's perfectly touching the top wall. All right, that's going to be our goal. And so now we have to have a ball. All right, we have to have a ball now. This first part was draw the bounding square. That is the walls. That was that. And now we need to draw a ball. But we can actually cheat a little bit. If we go to Python turtle documentation. Secretly, I told you that the turtle can be a turtle, right? Turtle.shape. Where is that? Appearance, shape. The turtle can be a turtle. The default was that arrow thing, right? The turtle can also be a circle. So let's use the turtle as the ball. Let's set its shape to be a circle instead of the turtle. So let's do that. Use the turtle as a ball. Make the turtle the ball. So turtle.shape. Oh, but sorry, that has to be a string. Excuse me. Really? Well, let me just use the mouse then. There we go. Turtle.shape circle. Won't that be fun? Watch. Now the turtle will be the ball. There he is. And we'll bounce him. We'll put him over here though. We got to move him. But that's the start. That's the start of it all. Let's make a cooler looking ball. Let's make the turtle. The turtle's color is whatever the fill color is set to. So let's say turtle.fill color. Let's make it a pink ball. Pink bouncy ball. That'll look a bit cooler, I think. And also, the turtle is a little bit small right now. Let's make it a larger ball. You can do that. You can resize the turtle. Turtle.turtle size or turtle.shape size. And then you stretch him in the width direction and the length direction by saying something like this. Turtle size 5, that makes him 5 times the size. All right, so let's do it that way. Make the turtle twice as big. Turtle size 2, 2. That's a nice looking ball. And so we're going to put that in the very middle, for now at least, and that'll be what we drop. All right. To help us later, I have done some math ahead of time. The size in this coordinate system that the turtle is using of the turtle right now, his width is 40. So I'll save that in a variable. Turtle width is 40. That's going to help us with some calculations in a little bit. So the turtle is has a diameter of 40 right now, 40 by 40, but it's a circle. All right, so we need to move the turtle right here, just ever so slightly touching the edge of that wall. All right, so let's get him there. We'd like the turtle to start, right here, right below it. So we can't, essentially, we want to make the turtle's x-coordinate, and we're going to use variables for this, and I'll show you why in just a second. So turtle, we want the turtle's x-coordinate, if we want him to always be in the middle, right? This is 0, 0 right here. So the turtle's x-coordinate should be 0, always, equals 0. The turtle's y-coordinate, though, it can't just be 200, because this is the positive 200 line, because it's always relative to where he is. All right, so I can't do something like this. Not quite. Turtle x equals 0, turtle y equals 200, and then we'll just always make sure the turtle goes to that spot. So put the turtle in the correct starting location. We never need to make a mark with the turtle ever again, so turtle.up. And then turtle.go to turtle x, turtle y. And so I'll just use these variables to keep track of where I want the turtle to be. All right? So we'll use these variables to keep track of where the ball should be slash where it should move to. All right, so that's a good starting point for the turtle, you might think, but it's not quite right. See how he's above the top wall there? We need to bring him down a little bit. So his correct starting point should not be exactly y equals 200 because half of him's over, right? We need to bring him down by half of his height slash width slash diameter, okay? So that's why I saved this variable right here. Because the starting part of the turtle should be 200 minus its width over 2. Okay? Bring him down by half his width. And that will work. Alright, 200 minus turtle width over 2. And that will place him exactly where I want him to be at the start. Alright, that is the starting point, and now I want to consistently keep moving that turtle forever until the end of time, down and up, hitting off the walls. Alright, that's going to be the idea. So, in between frames, I'd like to move the turtle ever so slightly, right? I want to change his x and y coordinate to be like not up here, but like down here a little bit now. Next time, down here a little bit. Each new frame, I'm going to move the turtle by a little bit, alright? And it's only the y-coordinate that's going to change because he's moving up and down. He's always staying with the same x-coordinate, right? But we'll change the turtle's y-coordinate to be a tiny, tiny bit. If he's moving down, it's got to be less each time, right? And we'll do this in draw frame. We'll make a function that handles drawing a new frame each time, right? And then we need to worry about bouncing off the ceiling slash floor, okay? So here is the idea. I would like to repeatedly, I'm going to make a function called draw frame, now that the turtle's in the right spot, def draw frame, that draws a new frame, moves the turtle a little bit, does cool stuff, right? So, ... and then I'm going to just repeatedly call that, while true, forever, draw a new frame. So all the important details will be taken care of by the draw frame function. Does that make sense? Now I just need to go and implement this. How in the world am I going to move the turtle a little bit each time? Right? So here's the idea. We have our turtle x, our turtle y, and then we need to save how much we're going to move the turtle each frame. So let's make that an offset. Let's call that the offset, turtle offset. Because we need to move them just a tiny bit each frame by some offset, let's say. It'll be constant because we want them to move at the same speed each time. So turtle.offset equals, I don't know, like -5, something like that. That's going to be how much I want to move or change the turtle's y-coordinate right now. If it's negative, that means it's going down, all right? Because the y should get smaller in that case. And then repeatedly, what I'd like to do in my draw frame, essentially, I'd like to change the y. Turtle y equals whatever it is plus the offset, plus turtle offset. And I'll do this once per frame, so I'm going to move the turtle by -5y each time. Do we see how that's going to make it all work? And then these are just variables, they're not actually moving the turtle anywhere. Then we have to actually redraw the turtle, have him go to that new place. Redraw the turtle. And this will give us animation. Are there any questions about why? Just repeatedly move the turtle by a tiny amount, which we're calling the offset, each frame, and depending on how fast the frame is being drawn, the turtle will move faster or slower. Also how big the offset is as well. So that's going to be the start. So I'd like to change, inside the frame, every time I draw a new frame, change the turtle's y-coordinate by the offset. All right, so turtle y is equal to turtle y plus turtle offset. And I'll put the offset up here. -5, we said. There we go. And because I am changing the turtle's y-coordinate each time, I need to make it global. If this is inside of a function, it's gonna yell at me. Python's gonna yell at me if I don't say global turtle y. I'd like to affect this global variable called turtle y. I'm also going to be eventually affecting the turtle offset. I don't need to do it right now, but I will need this later, so I'm just going to do it now. All right. So repeatedly, every frame, move the turtle by a little bit, change the turtle's y-coordinate, and then also redraw the turtle, of course, because I'm just messing with variables, not the turtle yet. So actually move the turtle to those new locations that we're trying to compute inside of those variables. Turtle.goto, whatever the turtle x, turtle y is now. It definitely has changed a little bit, right? So you start the turtle off here, that's at the very top, and then each frame we're moving the turtle by its offset. We're changing his y location by this offset and redrawing him there. If we do that repeatedly, we get animation. Oops. Of course I minimized it, sorry. Let's try again. Make this smaller. So if we do this repeatedly, we get animation. Watch. There he goes! And he just fell off the bottom. So we need to have him bounce off the wall. We need to have the turtle notice when he's at the bottom part of the wall, right? That's going to be the last step. So change the turtle's current y-coordinate to be a tiny, tiny bit more / less each frame. We're doing that in draw frame. We also need to make the turtle bounce when he hits the floor / ceiling. All right. So here's how we're going to deal with bouncing. All right. If we get to the very, very bottom, let's see, where do I want to put that? Let's just do it here. If we get to the very, very bottom, that means what is true about the turtle. Like this is the last place it can be before it crosses over. What is the last valid y-coordinate for the turtle? It's something involving -200 and width over 2. All right. If you do the calculation, you think about it long enough. So if we hit a wall, bounce off, if the turtle's y is going to be, if it's less than or equal to negative, it's going to be -200 plus turtle width over 2. That is, so this is -200 exactly. That's way too far off the wall. But if we increment that by turtle's width over 2, that's exactly the last spot the ball could validly be. If it ever hits this or tries to go past it, then we want to redirect the turtle. Does that make sense? So that's the very last coordinate that the turtle could ever be at. That is -200 plus turtle width over 2. That's the bottom wall, all right? So if this is true, if the turtle ever is equal to this or it's passing it, the turtle's y coordinate. So this means we either exactly hit the bottom wall or we're trying to go below it, which is also a bad thing. Or we're trying to go below it. In either case, we would like to make sure the turtle does not do that, right? First of all, move the turtle back inside. If he's strictly less than all this, make him exactly equal to the bottom wall. Let's do that. So set the turtle y to exactly fit on the bottom. And then also, we'd like to move upwards now. How can we move upwards? Instead of having our offset be -5, we can make our offset +5 now. Does that make sense? That'll make the turtle move up instead of down. Because we're always changing by the offset. If we change the offset itself, we can change the direction. Ooh, change the offset. So we move upwards now. So turtle offset equals whatever it was, turtle offset, times -1. It'll make it +5 now. So this offset is not just an offset, it's also a direction. Which is super cool. If we change it, we can change the way that the turtle moves. All right? So that's if we hit the bottom wall, bounce off. And then we'll notice that we need the same for the top. Going down, going down, going down, bounce off, cool. And now we flew off into space. So let's do the other way. We need to also check for that. That could be an elif, right? If, elif, else, or just to make it easy, you can't have both at the same time anyway, so let's just make it another if. Who cares? So if the turtle's y is trying to go over +200 minus width over 2, because that was the top part, right? 200 minus width over 2, that one. If we ever try to go above that, the y gets greater than or equal to, we've hit the top wall or we're trying to go over it. So we either hit the top wall or we're trying to go above it. In that case, we need to move the turtle back inside to like just ever so slightly touch the wall. So like rein him back in, and then make the offset change, make it negative now. So we can go downwards now. All right? So maybe if we were moving upwards, that means our offset was positive. We'd like to make it negative again so that the turtle moves downward. Okay? That will do it. Let's watch this. So this is just repeatedly draw a new frame. And all the bulk of the work is happening in draw frame. Look at that. We have a bouncing ball. Are there any questions about this code? So we move the turtle to the starting point. And then we just repeatedly call draw frame, which moves the turtle's y coordinate by the offset, whatever it is, and then checks for if we hit a wall. If we hit a wall, we try to go like past it or something. Then we want to reverse our direction, which means change the offset, multiply it by -1. If we were moving up, our offset was positive, we want to move down now, so make it negative. If we were moving down and we hit the bottom wall, if we were moving up and we hit the top wall, we want to make it negative. If we were moving down, we hit the bottom wall, we want to make the offset positive so that we start shooting upwards. All right, good with that? It's very interesting. Please study this program. It's a very cool program, I think. And Python's just trying to do this as fast as possible. Like, I don't have a delay. I'm not setting a frame rate. It's just however fast my computer can draw it. So maybe your fancy giant machines, the animation is faster for you because your computer's faster. But you can affect this also in your offset. If you'd like the turtle to move slower each frame, just change the offset to 2 instead of 5, -2. So now the ball will move at a more leisurely pace. Does that make enough sense? Any questions about that? It's a cute idea, I think. So I believe that is everything for this program that I wanted to show you. Please play around with this. I think the very last thing I wanted to show you is we never actually touch the x-coordinate, right? Because it's only moving up or down. We're like setting x to be 0. For fun, maybe we could set the x to be some random coordinate. That's my last idea. I'll have a random starting x-coordinate just to make it fun for us. So maybe instead of starting it at always 0 right in the middle, we can be like, I don't know, let's include the random library. And we'll set the starting x-coordinate to be random.randint. -100, somewhere between -100 and 100. So now every time I start the program, the x-coordinate is now maybe to the left a little bit, to the right a little bit. And so now the ball is dropping on this side. Everything else is the same. If I run it again, maybe it'll go to the right. Who knows? Yeah. Nice. So it's a different ball dropping each time. All right. So that's my fun example for us today. We'll add to this in a future lecture, though. We'll give it some real physics so it looks like it's actually falling on Earth, bouncing like it might in real life. We'll give physics to it. But that's the end of the slides. And the last thing that I wanted to show you today was your next extra credit assignment. So this will be due on the very last day of class, December, or the last day of classes. It's a Friday. We don't have class. But here is your assignment, if you'd like to do it. This is worth, again, up to 5% extra credit, if you'd like to do it. What I'd like you to do is, you've been learning a lot of Python, so I'd like you to make a video to help your peers, / maybe my future students if I want to, if you let me include it to them, review Python. Because I couldn't really ask you to do Scratch on the midterm. I can definitely ask you to write Python code on the final, and I will be, okay? Text is much easier than taking screenshots of boxes, all right? So do this to help yourself as well. So make a video to help review Python. You don't have to edit it or anything, just like start recording, click record, click stop, and submit it. So either upload it or submit like a public link to it so that I can visit it. So one way or another, get it on here. And here's what I want to see. So your video should be helpful to all the students who are going to study for the final, right? And who want to like review Python. So I'd like you to have a bunch of examples. Make some examples of Python concepts, ones that I've talked about in class, ones that you know you're going to be tested on. Please be creative, though. Make it as cool and as fancy as you would like, given what you know. The one thing you can't do, of course, is copy anything I did in class, because that is cheating, right? Got to do something new. So please, like, show what you're doing. Demonstrate the concepts you're teaching, that you're reviewing, just like you're a teacher, right? So maybe pretend you're me. Pretend it's a lecture. That might be helpful. So if you want the full 5% extra credit, make a 30-minute review video with a bunch of examples, or just maybe one very fancy example, I don't know. And if you want just half that credit, make a 15-minute review video. Okay? Are there any questions about that? It's pretty open-ended. Just review Python to help you and your peers study for the final exam, because there will be Python questions. And make sure you got to create something new. You can't just read off my slides or something. That's not fair. All right, I can help you pick a topic if you're interested in any of that, but I believe in your creativity. So that is your extra credit assignment. It's due the 2nd, which is 2nd of December, so exactly a month from now, which is a Friday. That's the last day of classes. It'll be due, I assume, midnight on that day. 11:59, December 2nd. So that's your extra credit, your final extra credit assignment for the semester. Please do it if you're interested. Any last questions about any of that or anything we talked about today? All right, that is all I've got for you.